Let us learn a problem on source and effect of magnetic field. Here there is a diagram given. Let us look at the diagram and get the details. Two concentric circle wire made of same materials are given here. The radius of the larger circle is 2 times the radius of the smaller circle. The current in each circles I1 and I2, and there is a potential difference maintained for the flow of current. In the first wire it is V1 and in the second wire it is V2. Right. Let us read the question now. Two circular coils, 1 and 2, are made from the same wire, but the radius of the first coil is twice that of the second coil. What is the ratio of potential difference applied across them so that the magnetic field at their centers is same? So let us first learn, the options are option A 3, option B 4, option C 6, option D 2. Let us learn the subject first, the path. The magnetic field at the axis of the coil is given by a formula B vector equals mu naught n I r square by 2 times r square plus z square to the power 3 by 2 k cap. Now, we take only one turn and we go for the center of the coil. Thereby, we get a simplified form B vector equals mu naught I r square divided by 2r cube k cap. Now, we have B vector equals mu naught I by 2r k cap. Now, let us keep this formula for our problem. This formula we will be using in our problem. So let us go for the next one, Ohm's law, because we are asked to find the ratio of the potential difference across applied V1 by V2. So let us learn Ohm's law, V equal to I times R. Here, the radius is given by, it is not radius, it is resistance is given by rho times L. What is rho? It is resistance per unit length of the wire, and L is the length of the wire. And the length here is the circumference of the coil, which is replaced by 2 pi r. This equation will also be helpful for us in solving the problem. So V equals I times rho 2 pi r. Let us go for the solution. So it is given in the problem. So B1 equal to B2. That is magnitude of the magnetic field at the center of the coil due to first coil equals the magnitude of the magnetic field at the center of the second coil. Here, the direction is not important. This direction of this magnetic field depends upon whether the current is clockwise or anti-clockwise. Then we have to use right hand thumb rule to find this direction. If the directions of the current are in the same direction, then the magnetic field will be added up. If the direction of the current in the coil are in the opposite direction, these two fields get each other. So let us not go in detail to the subject now. So it is given the magnitude B1 equals the magnitude B2. Okay, so we have a formula B equals mu naught I by 2R. Here I am taking for B1 mu naught I1 by 2R1 equals mu naught I2 by 2R2. Mu naught R are getting cancelled. I am getting I1 by R1 equals I2 by R2. But in the problem, it is very clearly given that R1 equals 2 times R2. Let us replace R1. So we get I1 by 2 R2 equals I2 by R2. R2 cancel. We get a relation I1 equal 2 times I2. Fine. So we'll go now to find the ratio of the potential difference. So we have a formula V1 by V2 equals I1 R1 by I2 R2. So V1 by V2 equals, we replace R1 by rho 2 pi R1 and we replace R2 by rho 2 pi R2. The common terms are getting cancelled. We get V1 by V2 equals I1 R1 divided by I2 R2. Let us replace I1 by 2 I2. Let us replace R1 by 2 R2. So we get V1 by V2 equal to 2 times I2 into 2 times R2 divided by I2 R2. So I2 cancels, R2 cancels. So the final answer V1 by V2 equals 4. This is the answer. Now to get the problem very simple, want to get it in within half a minute. So this formula that has to come to your mind first. From this has to be written on the paper, and this R1 has to be has to be replaced, and this is the next step should be followed. Right. The next one, you have to come with V1 by V2 equals I1 R1 by I2 R2. This is the next formula to be remembered, so that all the previous answers are substituted here to get V1 by V2 equals 4. So within half a minute, you have to solve this problem. You can solve the problem. All the best. Thank you.